Hello everyone. So yesterday we have started our backtracking section and we have solved three problems: subsets, combination sum, and permutation. So today we will try to solve some more backtracking problems. So let's start with the combination sum 2. Let's see what the question says. So the given a collection of candidate numbers and a target number, find all unique combinations in candidates where the candidates numbers sum to target. Each number in candidates may be only used once in the combination, and the solution set must not contain duplicate combinations. Okay. So the question says we can use every value only once, and also our the and every value once, and we need to add that values and find all the values whose sum equals to target. For example, here 1 plus 1 6 equals to target 8, and 1 plus 2 5 equals to target. And in this case we can use this 2 and this 2 and this one. This will also give us 5. This 2, this 2, and this one also gives us 5. But we don't need to use the duplicate values. Okay. Means we should avoid using duplicate values. Okay, so I think in the question it is not mentioned that our answer should be in sorted form, but someone in the discussion section is saying that it is required to provide a sorted solution. Means here we are giving the sorted arrays as the output. Okay, so as we need to return sorted arrays, what we can do is we can beforehand sort our array. So candidate, so we have sorted our candidates array as the output required in the sorted form. Okay, after that what we can do is we can call our utility function. First we can initialize our answer format. So this will be our answer format, and at the end we need to return this answer. And let's call the utility function. In utility function we need candidates array, and we need our index from which we start taking up values. So we will start from 0th index taking up the values, and then we can pass on our target. Then we can pass array list in which we will collect our current path, current answer, current array list of integer, and at the end we can put our answer. So let's initialize utility function. Candidates, instead of candidates let's call it array itself. Index, target, and our current path. So what we can call our current path? List of integer, let's call it current path, and also we have answer in our code, so let's call this answer. So whenever our index value reaches at the end, means we have iterated over the array and now we have nothing to iterate, we can return. So while collecting an element, we can do two things. First is skipping that element. So in order to skip that element, what we can do is we can increment our index value, and there will be no effect on our target, and there will be nothing added to the current path. So we just increment our index in this call. So that is the skipping part. Then another thing we can do is we can take that value. So in order to take that value, let's see what we can do. Okay, so in order to take that value, we can add that value to our current path. Means we are taking current value, means value at current index. So we are taking this value, and then we can move to the next index, as we can take on one index only once. So we, after taking a value, we need to move to the next index. Then what we need to do is we need to remove it from our target, target minus nums of index, and pass the current path and answer. And one thing, one check, additional check we can add is we can on beforehand we can check if our nums of index value is smaller than equal to target. Then only can we will take, then only we will decide to take that value. So that will make sure that our current doesn't becomes negative, and then we can remove that value from our current path. After taking that value, considering that value, current path dot remove. Okay, we need to remove the, wait a second, current dot path size minus 1, last value we are removing. Okay, so when we gonna add our current path to answer, when our target becomes 0, in that case we'll gonna add that our current path. So this will add a copy of current path to our answer, and then we can return. So we haven't handled duplicate values yet. So before doing that, we should see that how we are getting duplicate values. So we have current path. Okay, what error we are getting? Okay, so a return type is required here. Let's return void, because we are returning nothing. Okay, instead of nums we are using array. Okay, Do we have any another error? Yeah, here also we are using nums, so we need to replace it with array. Okay, so now we can see we are getting 2 and 6. We are getting 1 and 7. Okay. We are getting 1 2 5. Yes, we are getting. We are getting 1 1 6. Yes, we are getting. But we are also getting these two duplicate paths. Means 1 7 is already repeated and 1 2 5 is also already repeated. So we, as the question says, we only need to return unique paths. So how we can return unique paths? That's the question. So we can take a set also. Means we can take a set of a list of integer to store unique lists. So set will, let's initialize set first. Has set, new has set. Okay, I think we have done a mistake here. Okay, so we have initialized the set. So let's pass our set also in our call, function call. So now we are passing a set. So as we know, set only stores unique values. So whenever we reach a target, instead of, so we also need to pass set here. So instead of adding that value to our answer array, we should add it into our set. So one thing is we can remove our answer from our call also, that we are not using, we are only using set. Okay, so now we have a set. We are not passing answer. Let's return new array list. So this will give a empty array list. So now we are storing our all the paths in set. So let's print our set and check if we are getting all the unique values in the set or not. So for list of integer, list in our set, let's print our list. So let's see if we are getting unique lists in our set or not. So we have got an error. So this was a, I think we need to return like this, list of, okay, can we pass here only list, empty list? Okay, so I think now we are getting 125 26 116 17. Now we are getting unique values. So we can now return our lists present in our set. So this will put our all the list present in set into new list. Okay, so I think we can submit this approach. Okay, we are getting TLE here. So what we can do here? I think using set is not efficient. Means first we are iterating all the calculating all the paths, then we are putting it into set. I think we need to find a way where we can do is we can first make sure that the current list is not duplicate. How we can do, we need to think that. Okay, how we can find it? Let's see. We have these much ones. I think using a set of list is causing issue. Can we take a string instead? Means instead of set we can use a string, and we can check if that string is present in that set already, then we will not add that to our answer. If that can work, that I think that can work. Comparing string and list should be a different operation. Let's see if that works. Suppose we take a string here and initially we pass an empty string. So string, let's say a string builder. New string builder. So in Java we take string builders, means it is same, nothing else, but the only difference is string builders are mutable and strings are immutable. So using means string builders can be modified and strings cannot be modified, means we can modify strings, but uh, under the hood the Java will create a new string instead of modifying. So we will that is why we will use string builder for efficient removal and addition of strings. So this is our string builder SB. So we will also add to current path and also add that value to sb.append array of idx, that value plus we will add a star. Okay. Let's say this is string, but we also need to remove this value. So how we will gonna remove this value? That's the main question. So the length will be, so the string which we will be appending will be this string. Okay, and we will be adding that string to our string builder, and after we need to remove that string. So let's see how to remove substring from a string builder. String builder delete start and end. This method accepts two parameters: index of the first character of the substring, index after the last character. Okay, so sb.delete, so start index will be sb.size minus s.length, and end index will be sb.size itself. For example, we have this string 1 2 3 4 5 6, so its size is 6, and suppose we need to remove this element, this last two elements. So 6 minus 2 will give me 4. So 0 1 2 3 4, so it will start removing from here. Yes, so we are removing it correctly. So we will check. But this will have no impact, I think, because we are still iterating all the paths. Let's see if sb, if set dot contains If set doesn't contains sb.toString, if it doesn't contains this string, then in that case, let's say we have answer, what we will do, we will add our current path to our answer. So let's initialize our answer globally for once. And we will put that value to our set. Okay, we need to pass string builder from these calls, in these calls also. Okay, we don't have sb.size, we have sb.length. Okay, let's see if that TLE case is passing or not. Okay, we are still getting TLA. I think set was not causing issue. All the paths which we are tracing means we need to reduce number of paths which we are tracing. Let's see what I have done in my previous submissions. So it was in 2022. I have sorted the array. Okay, taken the answer, sorted the list, called the find function, and have same condition. If target is equal, then added that path into our this list. If target, and also checked i's condition, also added and removed the current path. And this is the only thing we are doing there, doing additional. So we are checking if our index is smaller than candidates or length minus 1, and candidates, if two consecutive elements are equal, then we are just moving forward. So this is also ensuring that duplicates element don't let me copy this. This line of code reducing complexity and explain with example. For skipping duplicate candidates, it ensures that the same number is not reused at the same recursive level. which would otherwise result in duplicate combinations in final answer. This have taken the same example GPT, which is described in the description. Sort the array. After sorting array, recursive exploration. Second call, third call, skipping duplicates and backtracking. So GPT is saying that on the same recursive level means we we are skipping the duplicate values. Okay, so we don't need to use all these things. The solution have become now pretty easy. Array list, current path, adding to current path and removing from current path. Okay. Okay, while our index value is smaller than -1 and our array of index is equals to array of idx plus 1, till then we will move our idx value ahead. So this was the main logic. Okay, we need to remove that variables from this call also. So what? Okay. Okay, we have skipped this value also. We have skipped all the duplicate values. So first we need to use that duplicate value, and after that we need to remove that value. So first we need to use that value, after that we need to remove that value, and after that we need to skip that value. Okay, so this test case is passing now. What if we first skip our value, and at the end I think this will not make any difference here. Okay, we are still getting TLE, so first we need to take that value and remove all that values related to that values, and then we can move forward. We have an option that we can skip or take the next value, means this will call for the next value we are reached. It ensures that the same number is not reused at the same recursive level, which would otherwise result in duplicate combination in the final answer. If candidate I equals to candidate I plus 1, there is no need to explore combinations starting with both candidates I and I plus 1 at the same recursive level. This is because the numbers are the same and would result in identical combination. By skipping duplicate numbers, the algorithm avoids redundant calls and explores unique combinations. If the while loop to skip the duplicate is removed, they include duplicates combination like multiple times. Okay, so we are not considering a same value at the same recursive level. So we are currently at this level where idx, we have a value idx. So we can use that duplicate value at the next level at idx plus 1. This optimization is critical for handling cases with repeated numbers. So we were getting TLE in the repeated number case itself. So we were calling at the same level with this one for every one we were calling our function. Okay, so let's submit this approach. Okay, it's pretty fast. So this was the key idea. Yeah. Okay, so let's move to the next question. Subset 2. So given an integer array nums that may contain duplicates, return all possible subsets, the power set. This solution set must not contain duplicate subsets. Return solution in any order, and our lengths are between these values, means from 1 to 10, and numbers are between -10 to 10. Okay, so we have given this set, and we need to return the power set, and the power set should not contain duplicate values, and we should return the answer in any order. Okay, let's see how we can solve this problem. Our solution should not contain the duplicate values. For example, 1 and 2, uh, and this one and this 2 can make a duplicate, but we don't have any duplicate here. Means we don't need to return duplicate in the answer. This solution set must not contain return solution in any order. Let's first write code to find all the power sets, means all the subsets. So we will initialize our answer array list. Okay, then we call our utility function with nums, and we will start with index and index 0 and our empty current path. And with our answer at the end, we will return that answer. So we will define our utility function, our index, our current path, and our answer. If our index reaches nums.length, in that case we need to add our current path to our answer, and need to return. So we have two options. We can skip our current selection, means we can skip taking current element, and we can just move forward. Otherwise we can take the current element and add to it our current path, and then can call our utility function with our current path, and then we can backtrack, we can remove that from our current path dot size -1. So we haven't handled the duplicate case all here, so let's see what duplicates we are getting. So we are getting duplicate values here. we are getting 2 times, and 1 2 also 2 times. So we need to remove these duplicate values, means we need to handle these duplicate values. In the case 2 we are getting correct output because we only have one distinct value, so no duplicates in the input. So now we need to remove the duplicate values. So let's think how we can remove the duplicate values. Given an array that may contain duplicates, the solution must not contain duplicate subset. Return the solution in any order. Where does the output should be in sorted order? This may further need explanation or refinement. I think here also we need to return answer in sorted order. Let's see for let's modify a test case. Our test case, let's call this 3 and see if our test solution is in sorted format. Yeah, instead of 3 2, expected solution is 2 3. So like previous question, in this question also it is not mentioned that this should be in sorted format. Arrays dot sort nums, so we will sort our numbers. So after sorting numbers we can see that now we are getting 2 3. Okay, so we have sorted our array. Now we need to remove duplicates. Okay, so how we can as our length is 10, so can we use the string format, because here the only length is 10, so can we store the something like string into the set? because we cannot use previous logic here because we don't have any target and we can have uh, these multiple values as the subset. Let's see. Let's see if the previous approach also works here. I don't think it should work. Smaller than nums dot length. Okay, so it's working. Means it's removing duplicates. Okay, so we can remove duplicate using this value also. Means this line, this code of line, what we will this will do, this will remove all the duplicate values from this level. Currently we are at this level, idx level. At this level it will remove all the duplicates values and move our skip call to a non-duplicate value, but our next utility call will be to a duplicate value. For example, if we consider this example 222 and we are here, so we are considering our current path and we are calling our utility function, but after this call is completed, our this function will make our idx still here, and then our skip function will return us nothing. If we have a 3 here, then our skip function would directly jump to the 3 value, and this call moves to this 2, and at this level it removes all the duplicate values and again moves to the next level. So in this way it is removing duplicate value at a level. So I think this is a takeaway from today's problem solving session, means how we can remove duplicates from permutations and subsets. Okay, so I think that is it for today. Thank you.